Good morning, class 12. As we have done the differentiation of different functions, now we will study applications of derivatives in various disciplines. For example, in engineering, science, social science, and many other fields. For instance, we will learn how the derivatives can be used. Number 1, to determine rate of change of quantities. Number 2, to find the equation of tangent and normals to a curve at a point. And number 3, to find turning points on the graph of a function, that is maxima and minima. So today we will discuss rate of change of quantities. Recall that by the derivative ds over dt, we mean that rate of change of distance s, rate of change of distance s with respect to time t, with respect to time t. In a similar fashion, whenever one quantity y varies with another quantity x, satisfying some rule for y equals to fx, then dy by dx represents the rate of change of y with respect to x. Exercise 6.1, question number 1. Find the rate of change of the area of a circle with respect to its radius when r equals to 3 centimeter. Radius is given 3 centimeter. So we have to find the rate of change of area of circle. So area of circle is pi r square and radius is given 3 centimeter. Now area, rate of change of area with respect to radius. So differentiating area with respect to radius, that is dA over dr, equals to pi as it is r square. Differentiation of r square is 2r. Now pi into 2 and radius is given 3, so which is equals to 6 pi centimeter square. So this is the rate of change of area with respect to radius. Second question, the volume of a cube is increasing at the rate of 8 centimeter cube per second. So volume of a cube is increasing. dV over dt is given 8 centimeter cube per second. How fast is the surface area increasing when the length of an edge is 12 centimeter? So let edge of cube equals to x centimeter. Now volume of cube is side cube, so b equals to x cube. Now if we differentiate with respect to t, so dv over dt equals to 3x square into dx over dt. Since we are differentiating volume V with respect to time t, so we have to put here dx over dt. Now dv by dt is given 8 equals to 3 and x is given in the question, length of edge is 12 centimeter. So it is 12 square into dx over dt. After solving it, we can find dx over dt will be equals to 1 upon 54. Now we have to calculate how fast is the surface area increasing. So surface area of cube is 6 into side square. So s equals to 6x square. Again, if we differentiating this equation with respect to t, it will be ds over dt equals to 6 into x square. Differentiation of x square is 2x into dx over dt, which is equals to 12, and in place of x again 12. Value of dx over dt is 1 upon 54, which is equals to 8 upon 3, and unit will be, since it is surface area with respect to time t, so centimeter square per second. Question number 5. A stone is dropped into a quiet lake and waves move in a circle at the speed of 5 centimeter per second. So waves are moving in circles. So let radius equals to r. Now since waves are moving in circles at the speed of 5 centimeter per second, so it is dr over dt equals to 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, when radius is 8 centimeter, how fast is the enclosed area increasing? So area of circle is pi r square. If we differentiate it with respect to t, dA over dt is 2 pi r into dr over dt. So 2 pi, radius is 8 and dr by dt is 5, which is equals to 80 pi area, rate of change of area with respect to time t. So unit is centimeter square per second. Question number 7. The length x of a rectangle is decreasing at the rate of 5 centimeter per minute. Length is decreasing at the rate, so dx over dt, and it is decreasing, so we have to put minus sign, minus 5 centimeter per minute, and the width y is increasing at the rate of 4 centimeter per minute. So dy over dt, it is increasing at the rate of 4 centimeter per minute. When x equals to 8 centimeter, x equals to 8 centimeter, y equals to 6 centimeter. Then we have to find rates of change. Number 1, the perimeter, and number 2, area of rectangle. So first we will calculate rate of change of perimeter. So perimeter of rectangle is twice length plus breadth. So perimeter equals to twice length is given x and breadth is given y. Now if we differentiate it, it will be dp over dt equals to twice dx over dt, differentiation of x with respect to t, and differentiation of y with respect to t is dy over dt. So twice dx over dt is minus 5, dy over dt is plus 4, so which is equals to minus 2 centimeter per minute, rate of change of perimeter. Now in the second part, we have to calculate rate of change of area. So area of rectangle is length into breadth. Area equals to x into y, differentiating with respect to t, dA over dt. Here we have to apply product rule. First function, differentiation of y is dy over dt. Second function, dx over dt. So x is 8, dy by dt is 4, plus y is 6, and dx over dt is minus 5. So if we solve it, we will get 2 centimeter square per minute. Rate of change of area with respect to time t is 2 centimeter square per minute. Question number 10. A ladder 5 meter long is leaning against a wall. This is the ladder leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall. This is pulled, this is bottom of the ladder pulled along the ground away from the wall at the rate of 2 centimeter per second. So if we suppose it x, so it is given dx over dt equals to 2 centimeter per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? We have to calculate how fast is its height decreasing. So if height is y, so dy over dt we have to calculate when x equals to 4. If we pull the ladder away from the wall, its height will be decreasing. Now when x is 4 meter and rate of change of pulling the ladder is given in centimeter per second. So we can convert this into meter per second. So it will be 0.02 meter per second. Now in triangle ABC, we can apply Pythagoras theorem. So it will be x square plus y square equals to 5 square, that is 25. Differentiating with respect to t, 2x dx over dt plus 2y dy over dt, differentiation of 25, that is constant, is 0, divided by whole equation by 2. So x dx over dt plus y dy over dt equals to 0. When x is 4, dx over dt is 0.02. Y dy over dt equals to 0. Now we have to find the value of y. Since x square plus y square equals to 25, when x is 4 meter, so 4 square plus y square equals to 25, so y equals to 3. So it is 0.08, y is 3, dy over dt equals to 0. So dy by dt equals to minus 0.08 over 3, which is equals to minus 8 upon 300, which is equals to minus 2 upon 75 meter per second. Minus sign is denoting that height is decreasing. So today's homework is you have to complete exercise 6.1 from question number 1 to question number 18. Thank you, children.